Hello everybody, it's your favorite pod instructor, Miss Tati. I am here to tell you guys about how telescopes work. So we are actually going to read off of two articles so that you guys can have two different perspectives of how telescopes work. One is by Dr. Craig, and I'm going to chop his name, I apologize, Dr. Fred Friedenreich. And this is at our science science.howstuffworks.com/telescope1. So that's where you can find that at. So just so you guys can see that website right down at the bottom. And yeah, so that's that, and it's gonna do that, and we'll come back and you'll be able to see what a refractor is. I'll pause and make sure I show that. So this is the simplest telescope design you can have, which is the refractor telescope, and it's a big lens that gathers the light and directs it to a focal point, and a small lens that brings the image to your eye. So that's like that simple telescope that we usually see, the Pirates telescope or the simple regular telescope that's big on the tripods. Those are what we usually utilize. So a telescope is an amazing device that has the ability to make faraway objects appear much closer. Telescopes come in all shapes and sizes, from a little plastic tube you buy at a toy store for $2 to the Hubble Space Telescope, which weighs several tons. Amateur telescopes fit somewhere in between, and even though they are not nearly as powerful as the Hubble, they can do some incredible things. For example, a small 6-inch, which is 15 centimeters, scope lets you read the writing on a dime from 150 feet away. That's 46 meters away. So that's like if you were crossing the street, that's about 150 feet away. If I was on one side of the street and you were on the other. Most of the telescopes you see today come in one of two flavors. And that's what I was just speaking of. That's the refractor telescope, which uses glass lenses, and the reflector telescope, which uses mirrors instead of the lenses. So our micro observatory telescope that we are using in our program is a reflector telescope. Both types accomplish exactly the same thing, but in completely different ways. To understand how telescopes work, let's ask the following questions. And get your pen and paper out. Let's answer these questions before we go into the answers. Why can't you see an object that is far away? 2 minutes. For example, why can't you read the writing on a dime when it is 150 feet away with your naked eye? to write your answers in the comments. The answer to this question is simple. The objects do not take up much space on your eye's screen, and your eye screen is your retina. If you want to think about it in digital cameras terms, at 150 feet, the writing of the dime does not cover enough pixels on your retinal sensor for you to read the writing. So even on a regular camera, you wouldn't be able to. If you had a bigger eye, you could collect more light from the object and create a brighter image. And then you could magnify part of that image so it stretches out over more pixels on your retina. So let me tell you this, right? So you see how it says your bigger eye, you could collect more light. So in order to see things, what happens is the light hits your eyes, and then your eyes can see the object. So the light from the sun reaches your eyes, and then you can see the tree in front of you. That is how your retina works. Two pieces in a telescope make this possible. The objective lens, which in refractors, or primary mirror, which is in reflectors. They collect lots of light from a distant object and brings that light or image to a point or focus. An eyepiece lens is the second object that makes this possible, and it takes the bright light from the focus of the objective lens or primary mirror and spreads it out. That means it magnifies it to take up a large portion of the retina. This is the same principle that a magnifying glass lens uses. It takes a small image on the paper and spreads it out over the retina of your eye so that it looks big. When you combine the objective lens or primary mirror with the eyepiece, you have a telescope. So I'm going to say that again for you guys, alright? When you combine the objective lens or the primary mirror with the eyepiece, you have a telescope. Again, the basic idea is to collect lots of light to form a bright image inside the telescope, and then use something like a magnifying glass to magnify and enlarge that bright image so that it takes up a lot of space on your retina. A telescope has two properties: how well it can collect light and how much it can magnify the image. A telescope's ability to collect light is directly related to the diameter of the lens of the mirror, which is the aperture that is used to gather light. Okay? Generally, the larger the aperture, the more light the telescope collects and brings to focus, and brighter the final image. Just like they say, if we have bigger eyes, same thing. So the aperture, the bigger that is. The telescope's magnification is ability to enlarge an image. That's what magnification means, okay? It depends on the combination of lenses used. The eyepiece performs the magnification. Since any magnification can be achieved by almost any telescope by using different eyepieces, aperture is a more important feature than magnification. We could switch out our eyepieces to make them different. To understand how this actually works in a telescope, let's take a look at a refractor telescope. The kind with lenses magnifies an image of a distant object that makes it appear closer. So we are going to go look into that, but we're going to go back into more of how telescopes work, okay? So that was our first article. Hello everybody, it's me again, your favorite pod instructor, Miss Tati. I'm here to provide you guys with another How Telescope Works article, and this is provided to us directly from NASA, okay? So the short answer, right? Let's get straight to it. Early telescopes focused light using pieces of curved, clear glass called lenses. Where else do we have lenses? Can you guys drop that in the comments? Tell me where else do we use lenses at? Alright, I hope you guys had a great time writing down your answers. So a telescope is a tool that astronomers use to see faraway objects. Most telescopes and all large telescopes work by using curved mirrors to gather and focus light from the night sky. The first telescope focused light by using pieces of curved, clear glass called lenses. So why do we use mirrors today? Because mirrors are lighter. and they are easier than lenses to make perfectly smooth. The mirrors or lenses in a telescope are called the optics. Really powerful telescope can see very dim things and things that are really far away. To do that, the optics, it can be the mirrors or lenses, has to be really big. The bigger the mirror or lenses, the more light the telescope can gather. The light is then contracted by the shape of the optics. That light is what we see when we look into the telescope. So when you see light, first you see light and then you see your object that you see, because the light from the sun first hits your eyes and then it allows you to see. And that is a fun fact. Okay. The optics of a telescope must be almost perfect. That means the mirrors and lenses have to be just the right shape to concentrate the light. They can't have any spots, scratches, or other flaws. If they do have such problems, the image gets warped or blurry and is difficult to see. And you guys can actually find that out, what happens to the Hubble when that happened. And it's called Adventures in Space. If you go check out our feed, we actually read that book out loud, and it tells you about the Hubble's trouble. Yes. So, it's hard to make a perfect mirror, but it's even harder to make a perfect lens. So lenses. A telescope made with lenses is called a refracting telescope. So which one of our telescopes is made with lenses? That's right, boys and girls, our refracting telescope. A lens, just like an eyeglass, bends light passing through it. In eyeglasses, this makes things less blurry. In a telescope, it makes faraway things seem closer. People with especially poor eyesight need thick lenses in their glasses. Big, thick lenses are more powerful. The same is true for telescopes. If you want to see far away, you need a big, powerful lens. Unfortunately, a big lens is very heavy. Heavy lenses are hard to make and difficult to hold in the right place. Also, if they get thicker, the glass stops more of the light passing through them. Because the light is passing through the lenses, the surface of the lens has to be extremely smooth. Any flaw in the lenses will change the image. It would be like looking through a dirty window. So why do mirrors work better? A telescope that uses mirrors is called a reflecting telescope. Can you tell me which telescope uses mirrors? That's right, boys and girls. It's the reflecting telescope. You guys are awesome. I love that you guys are paying attention. Unlike a lens, a mirror can be very thin. A bigger mirror does not always have to be thicker. Light is concentrated by bouncing off of the mirror, so the mirror just has to have the right curved shape. It is much easier to make a large near-perfect mirror than to make a large near-perfect lens. Also, since mirrors are one-sided, they are easier than lenses to clean and polish. But mirrors have their own problems. Have you ever looked into a spoon and noticed your reflection is upside down? The curved mirror in a telescope is like a spoon. It flips the image. Luckily, the solution is simple. We just use other mirrors to flip it back. So what does the small mirror do? The mirror that is curved in a telescope is like a spoon. So it flips our reflection upside down. And they utilize other mirrors in order to get them back to the same way so we can see them upright. Yes, that's awesome. The number one benefit of using mirrors is that they're not heavy. Since they are much lighter than lenses, mirrors are a lot easier to launch into space. Space telescopes, such as the Hubble Space Telescope and the Spitzer Space Telescope, have allowed us to capture views of galaxies and nebulas far away from our own solar system. Set to launch in December 2021. So how many years ago was that, guys? Great job. Great math problem. Yes. December 21st was 3 years ago. The James Webb Space Telescope launched. It is the largest, most powerful telescope ever built. It would allow scientists to look at what our universe was like about 200 million years after the Big Bang. Yes. If you have any questions, please drop them in the comment. I'll be sure to respond back. Thank you. Enjoy.
Now that we have learned, let's reflect. What is a telescope? What is the difference between the refractor telescope and the reflector telescope? What in a telescope is similar to your retina in your eyes? Which telescope uses glass lenses? Which telescope uses mirrors instead of lenses? What is an objective lens or a primary mirror used for in the telescope? What does the eyepiece lens do? What is more important, the aperture or the telescope magnification? Why? Name 2 telescopes mentioned.